Okay, you are welcome. Let's continue with our lesson. Okay, as I said earlier, we have some renowned Ghanaian electronic professionals that we can't leave out. These days, we wouldn't be mentioning the whites. We will only use people from our locality. So that one can give you a motivation. You see, those from Kumasi, I think I've forgotten of where this man is coming from. He's coming from one place. I've forgotten of the name. But I have a lady friend whose family is related to this man. So she actually told me that the man is from their area. So you see, when we come to Ghana, we have the what the men. So this man is called Dr. Thompson, also means he brought in fiber optics. He's the one that invented fiber optics. When you hear of fiber optics anywhere, he's the first person to bring that research into being. So you see, Ghanaians, we are not kids. He has done a lot of achievements. He has developed fiber optic manufacturing technology. Then he is still working with, is it Corning Institute in US. So you can search for him and also talk to him. I know some of you are related to him. He's from Ashanti region. So we go to the next one. Let me share this my thing well. Okay, so we are done with us. Then the next one is Apostle Kojo Safo. That one everybody has heard of him. That's Kantanka, an inventor and an industrialist. The man is very powerful. Please read about him. Try to be like him and follow his steps. You will make it in Ghana here instead of even traveling abroad. So read about him. I've been reading about him a lot. And he's the one that motivates me. Sometimes I program to the daybreak. I can sit by a PC around 9 p.m. Sometimes I sleep early. I sleep early around 5. Then I wake up around 9. Sit by my PC. See, the electronic programming, it needs time. It's not like the software programming. I can program till daybreak. Why? Because I know these people are Ghanaians. They have done it, and I also do it. So please, don't be running away from this kind of programming, electronics, and all those kind of things. Use these people to motivate yourself. He's a founder of Kantanka Mobiles, Automobiles. Ghana's first indigenous car manufacturer. He has manufactured a car. And his electronic works too is very, very powerful. He designed embedded systems for vehicles, like as I said earlier, including AI-based safety features. These days, he is even incorporating AI into a system, chatbots and other things. Please visit these people, visit them. Then you see what is going on in technology so that one day you also, I know you are even at a point of entering into industry. So don't be playing with some of these things. So use these people as a motivation. Yes, we have a very powerful lady here. As I said, biomedical engineering is where you apply your IT and electronics into the health sector. And this lady, most of you know her through Ghana Science and Maths Quiz. That is her area. She's a biomedical engineer. And you see the way she talks, she does a lot of innovations in the industry. She hosts, let me see, for her roles, she hosts Ghana's National Science and Maths. So please, the ladies, use her as your motivation. She promotes engineering in what? In education too. Then as a biomedical electronics and what? Prosthetics. That one too, she finds herself in the what? In the medical field. So that is it for now. Then there's this man called Herman Oula Kojo Shinri. So this man, people call him the first Bill Gates of Ghana or the Bill Gates of Africa. When he started building softwares, I don't think some of us even had ever touched a mouse before. But he's a founder of SoftTribe. Please search for him. Ghana's first software and hardware solution company. I've forgotten of where he's based, either in Accra or Kumasi. But look for him. Look for him. So he developed payment systems and IT solutions for what? African markets. Please look for him. He's another big motivation person. Then we have this man too called, let me lift my thing small so that you see it. There's this man called Ashite Trebi Oliunu in NASA Robotic Engineers. He's a NASA Robotic Engineers. He's in that engineering field. So look for him too. He's in US and he's also another powerful guy in the electronic industry. He leads engineers for what? NASA's Mars rover mission when they were to launch one of their their missions into the planet Mars. He was one of the pioneers over the world, or one of the principal guys who work for the success of what? That kind of launching. He works on the robotic arms always. So he's a mentor Ghanaian engineer through what? Ghana Robotic Academy. So look for them. They have this lady, very powerful lady, Regina Jari. So she is very common. She is found in what? Training her maids, training kids, training other students. Especially she concentrates on ladies a lot in robotics. And she's very powerful. Please look for them. You'll get their contacts online. She's a founder of what? Shurunku Solution, promoting STEM for what? Girls. You know STEM, the meaning of STEM. Then Electronic Link. She trained youth in coding and hardware integration. Example, Arduino, as I'm doing here. I also have a lot of Arduino kits here. Now I'm having not less than 10. I have a lot, about 12 or whatever. So that is it. She's also a lady. Then we can't leave out another powerful man. So I'm the one. You should also know about me too, because I'm also an electronic engineer. And I've also excelled a lot in electronics. I had the opportunity to meet most of the presidents. Why? Because when students are to do exhibition of electronic projects, hackathons and all those kind of, they find me there. So I have the opportunity to also talk to some of the presidents. You get what I'm saying? So I'm actually a teacher, but let me say, teaching is not a bad job. It's a very powerful job. It gives you connection. As I'm talking to you, you who are getting to more than 1,000 or let me say 800. So it's possible one day I will meet you guys when you become big men or women. And I know I'm going to meet you and you are going to also give me what I need based on how we related. So I'm your data electronic lecturer and a mentor who has guided students to win innovation challenges. When it comes to hackathon and all those kinds of things, please, I'll be sharing a flyer with you. Try and communicate with me through that flyer. That is where I train people for hackathons, for training and competition. Me, right from childhood, I like competition. I don't know why. Yes, I like competition. Anything competition, I want to be part. So I have grown with it. And when I see students who want to go for a challenge, students who want to go for competition, I try to work with them, give them the stuff, the tips, and all the packages they need for that. So try and communicate with me when you see the flyer. Build real-world tech projects and launching promising careers. You see, most of my students are now in big places. Some are in Newmont, VRA, and whatever, and they always remember me. I'm here not to just teach you circuits, no, not only for electronic circuit, but to help you discover how this knowledge can power your future in technology and engineering. That is it for now. Okay, so that is our objectives. As I said, I've updated the content of my slides. So try and read it to provide a comprehensive understanding of fundamental principles of both analog and digital electronics. There are differences between them. So when I get to class or as in the course of the lessons, you understand what I mean. To equip students with the ability to analyze, you should have the power to analyze a circuit and implement basic circuits, electronic circuits and digital systems. So to develop practical skills. So in here, we need practicals. You see, the practicals is in two forms. Listen to what I'm talking to you, what I'm saying very well. We have simulation, then we have the real practical, which is physical. The real practicals comes with costs. But for the simulation, we can use a computer to do it all the time. But simulation is just like, let me compare this for you to see. You can be in your room and play football, not so? You can. Why? Because I can use a TV game to play football and I'll play it perfectly. You can even use that to win a bet. But does it mean you have won boots and holes and whatever to go to the field to play? That is the difference. You see, you can play it in the room, sitting by your PC. That is simulation. But for the real practical sense is when you go to the field and start playing yourself. So that is it is in two ways. So I'm going to analyze this. You see, we will be dealing with a lab manual. You call it logbook, please. Don't be playing with the logbook. And I think it's 12 CDs. One is 12 CDs. I'm selling my 12 cedis. I think it's the order from above that we should sell it at 12 cedis. So don't pay to the class reps to go and that one keep them busier. That's what I see. Whenever it comes to lab logbooks, the class reps are always stressed, or you keep them busy. Instead of them concentrating on the class, they'll concentrate on sharing of logbooks and whatever. I've been seeing it. So what I want to do is that I'll give you, or you can even use my number. My number is just there, and send me the memo. But when you are sending the memo, please listen to this carefully. When you are to send the money, there's a reference area. I don't know whether when that thing comes to my phone, that reference I will see. Yes, I will definitely see the reference. So when you send the money, the reference has to be your index number, because those index numbers, my TA will copy them onto the what? The logbook. So when we come, we are going to share the logbook with those numbers written on the what? In your reference. So he will look through. When you send the money to me, use that one as a reference. But by mistake, you send and you don't use that one as a reference, then it will make the work difficult. So send the money to my number, 12 CDs, you send it to my number, but use your index number as the what? The reference. But don't forget to add your class name. That is E, A, B, or what? D. If your class is A, after typing your index number, you add the A to it. Use that one as a reference. Don't pay anything to any class rep or any TA. Send it to my number. Just do this for me. When I'm coming to class, I'll come with those kind of what? Logbooks. Then we use it. So that is that for now. But then that one will be for the simulation aspect. That is what we will be doing in class. But then how do we do the practicals? Once a while, I'll bring the components to class for us to deal with. But if you now want to go further to learn the practical, like if you are targeting any competition somewhere, because I have my own competition that I'm going to organize at Eastbase Hotel somewhere around December. And I know December, most of you will not be around. So if you will not be around, I don't think you should be worrying yourself. But then there can be a way out. Maybe you might be giving some money to travel and come and compete. So with that, I'm training some guys. So I have a flyer I'll share with you on the page. So after seeing the flyer, just communicate with me. There are a lot of things that I'll show you. But that one comes with a cost. I always train the students on Saturdays. So that one you have to pay. That's the other side. That one is the real practicals. Though the real practicals, there's no components to do it in class. So we will do only the simulation. Then we put that one in the logbooks for marking. So that is it for how the practicals will go. Yes. So now let's see. To introduce students to operation of our electrical machines and integrated. So there, I'll be programming some projects for you to see. I have a project here. I'm going to meet STU students this morning. When they come and they finish, I'll let one of them demonstrate an alcohol sensor for you to see. So I'll share the video for you to see. Yes. So this is it. We'll be talking of Ohm's law and the rest. You see, we've not gone through it, so you might not be able to understand what I'm talking about. So we have logic gates and the rest. So we'll talk about them too. So microcontrollers, this is what rules the world. So I should be able to teach you microcontrollers. That's what we use to program electronic circuits or systems to work the way we want. This is not software program. This, yeah, what? Electronic and hardware programming. As simple as that. Okay, I think my thing has been duplicated. Okay, no problem. So you can delete that slide. So we have laboratory setups, as I said. Now, these are some of the books you can contact or you can be reading about. You see, because of ChatGPT, these days, students don't like reading, but please try and read. So that is it. This is the first lesson. We talk of some electrical quantities. What do I mean by electrical quantities? See, when it comes to these kind of electronics, there are some measurements you'll be doing. But when I'm measuring something, what am I measuring? I should know that maybe I'm measuring voltage. When I'm measuring voltage, what is the unit? If you measure voltage and you get 10, what unit do you attach to it? You attach V, which means volts, meaning you are measuring voltage. Where can we get those? We can get it from batteries. So maybe I'll come to class with a battery, then we all measure the voltage across the battery. The battery that is in your phone, you can measure. The battery that in the car, you can measure. Battery that in the torchlight, you can also measure on your own. So these are some of the things we'll be doing. So we have current. What do I mean by current? Current is another quantity. That one is different from the voltage. You can have the voltage, all right, but there will not be current in it, or the current will be down. So we have to be able to measure that one too. But that one, the symbol is what? Amperes, or the unit is amperes, and the symbol is A. If you want to measure it, there's an instrument called an ammeter. You use it to measure. So at the end of the day, you get something like maybe the charging in the phone charger, or the current, rather. The current that is found in the phone charger, you can measure it. One day we will do that. Then resistance. Resistance is another quantity. When current want to flow, resistance will block it. But how much resistance is in your circuit? That one too we might want to know. Because if you don't know it, you can't apply the right voltage and the current that will do the job for you. So you should be aware of the resistance. And that one too, the unit is ohms or ohm. And the symbol is what? That Latin symbol. Then the machine or the device or the instrument used for that is what? An ohmmeter. An ohmmeter. Yes. So we have about 100 ohms, 1 kilo ohm, and all those things. Then we have something like power. Power is the rate at which work is done. But when it comes to electrical, it's different. It's a different thing altogether. The formula is what? Voltage times current. So we look at that one too, and it is measured in watts. And the symbol is W. And we have an instrument called watt meter. So after measuring it, maybe you can have practical example, like maybe in an LED. This one, we don't call it LED. It's rather LED. The power consumption of an LED you can measure. Then the power consumption of a bulb. These days, when you're even buying a bulb, you look at the wattage. So people don't go for those with the highest wattage because they consume more. So that is it for now. Then we talk of energy. For energy, you have been interacting with this all the time. That is in kilojoules or kilowatt hour. You see, that's how we measure it. And when we say you are buying power from VRA, that is 30 units. It means you are buying 30 kilowatt hour because 1 unit is equal to 1 kilowatt hour. So that is it. We can have a device. You see, this one I can't bring it to class, but I'm just showing you the energy meter in your house. It just It's just an instrument used for measuring energy. And you can find it in our household electricity bills. As simple as that. One day you have to bring a copy of a bill to class. We will use it for something. I will show you something. I'm not going to show you how to do, you see me, I'm an electrical person. I did electrical before doing computer engineering. So I will not say I'm going to show you how to deal with the meter because the meter is not supposed to be attempted with. You see, in IT, there are ethics. There are some things you shouldn't do in IT. One, if I give you my phone and I'm having a picture on it and I say, oh, please watch this, my picture. Don't you see it's nice? After watching the picture, please don't scroll. That's not what I told you. I didn't tell you to scroll. So don't joke with those things, those ethics. If I give you my laptop to repair for me and you see a movie on it, don't open the movie. If you see a file on my PC, I've given you my PC to do something, don't open the file until I tell you to do so. Don't copy anything until I tell you to do so. That is computer ethics. Please adhere to that and you'll go far. If you do this, you'll go very, very, very far. That is it. So in electrical too, we have a lot of ethics. I'm an electrical person. There's something I can do to my meter and I will never pay any money. But it is what? Illegal. That's what we call illegal connection. And we have a lot of them. We have types. Most of them are very dangerous. Please don't ever try. Don't ever try. If you become a hacker, they can pick you in a company to be a computer security or cyber security personnel. It doesn't tell you that you should be hacking people. No, it doesn't go that way. You see, those who are network administrators in the bank, they have the ability to steal from you. Yes, they can do, but they will never do because of computer what? Ethics. Simple as that. So that is it. So there will be some calculations that we'll be doing. If I want you to calculate voltage, please look for the current, multiply it by the resistance, you get your voltage. Example, a circuit has a current of 3 amps flowing through a resistor of what? 4 ohms. Calculate the voltage across the resistor. We know voltage is equal to what? Current times resistance. Just multiply 3 by 4. Then you get your 12 volts. I don't think something like this will be difficult. And my objectives, about 40 objective questions. I know most of you will crash it before we go to the theory. The theory will be 20 marks. So if you crash the objectives, you are off to go. Then we talk of how to calculate current. Sometimes we can turn the question. Is it that a 9 volts battery is connected to a bulb with a resistance of 3? What's current flow through the bulb? You see, we know V is equal to IR. So if I now want the I, you just make I the subject. Simple. So I becomes V divided by what? R. So 9 divided by 3 will give me what? 3 amps. As simple as that. But don't forget to put the unit, which is what? A, or capital A. Then you have resistance. We have turned this one too. And so I'm using this one to test you to see whether you understand. So let's go to the next one. We have power. Power is always voltage times current, as I said. So because of that, you have to multiply the voltage. The voltage will be found like a phone charger operates at 5 volts and draw a current of about 2 amps of current. How much power does it consume? Please do that. Multiply by the voltage by current. Then you get your what? Your wattage. So most of the times, don't forget to attach the unit. That is watts and watts. Now let's go to energy. A 60 watts light bulb is left on for 4 hours. How much energy does it use in kilowatt hour or units? You see, always let your value be in kilowatt hour before you multiply by the number of hours. Because how to calculate energy is power times what? Time. So power should be in kilowatts. Then the time should also be in hours. If you were real electrical students, there would have been a lot of tricks. Instead of giving you the thing in hours, we would rather give it to you in what? Seconds, so that you convert. A lot of troubles. But this one is straightforward because you are IT student. You first convert the watts to kilowatts. That's the first thing you do. If you have a unit and you want to, a number you want to convert to kilo, you divide by 1,000. So there you get 0.06 kilowatts. Now, how do I get the energy? Energy is what? Power times time. And the time, make sure it is in hours. That is why we've multiplied 0.06 by what? 4 hours. Then we get our 0.24 kilowatt hour. So that's the number of units that bulb has been chopping from your what? Your meter when you leave it on for what? 4 hours. As simple as that. Fine. Oh, there's a practical question here. A Ghanaian household appliance rated at what? 230 volts and a power of what? Thus, what current does it draw? This one, you can know the current by dividing the power by what? Voltage. As simple as that. Okay, we'll be doing some simulations when I come to class. So let me end my class here. I think some students are waiting for me. I have a class with them. So this is it for our online class. Please, for the whole of this week, this is our online. But before you come to my real class, that's a face-to-face, make sure you've watched these videos before you come. So tell your colleagues to watch these 2 videos before they come to class. Simple. So thank you. We meet.